Hey, what's up everyone? My name is Jason Turley, and today we are back with some more TryHackMe content. Today we are looking at the hack room. The caption says, find out what happened by analyzing a .pcap file and hack your way back into the machine. A .pcap file is short for, is a packet capture. So it's a snapshot of network traffic that could have been captured with Wireshark or TCP dump. Looking at the first task, it says, oh no, we've been hacked. There's a little button to download the files. Let's do that. Or we can just open it directly with Wireshark, hit OK, and we see that there's a bunch of questions down here that need to be answered. And then there's another task, hack your way back into the machine. But let's start with the first task. All right, Wireshark's loaded here. I'm gonna place this on the left. All right, so Wireshark has opened up. On the left, you can see what packet number this is. And down here in the bottom right, we see that there's a total of 907 packets in this capture. It shows what time the packet was captured, the source and destination IP address, the protocol. We can expand these tabs. We can see what port was used to communicate. Port 21 is commonly associated with FTP by default, unless a system administrator changes it. Before we go any further, let's start reading some of these task questions. It seems like our machine got hacked by an anonymous threat actor. However, we are lucky to have a Pcap file. Can you determine what happened? All right, we already downloaded it and used Wireshark to open it up, so hit continue. The attacker is trying to log into a specific service. What is this service? So we can click and we see a bunch of requests to port 21, which is FTP. So let's use that as our answer. And we got that correct. There is a very popular tool by Von Hauser, which can be used to brute force a series of services. What is the name of this tool? We click on the hint if we wanted, and it just gives us the GitHub link. So let's go to that link. And they have a bunch of projects listed here. Let's look at this one. This one has the most stars and forks. So let's click on it. Hydra, we see a bunch of tags here, a bunch of keywords, brute force attacks, penetration testing, password cracking, brute forcer. Scroll down, let's look at the README for this. One of the biggest security holes are passwords, as every password security study shows. This tool is a proof of concept code to give researchers and security consultants the possibility to show how easy it is to gain unauthorized access to a system. So this is the tool to help us brute force passwords. Some of the protocols that it supports, we see FTP listed here. We see different kinds of HTTP services, LDAP, and a bunch more. So the answer to this would be Hydra. That's the name of the tool, and it's built into Kali Linux by default, which is pretty neat. The attacker is trying to log on with a specific username. What is the username? The hint just says look at the FTP request. So a neat trick with Wireshark is for any packet, you can right click it and you can go down to follow. And this is a TCP protocol, so we want to follow the TCP stream. So click there, it's the only option we have anyway. And it's just going to organize the data from that TCP packet capture for us. We see hello FTP world, we see user Jenny, please specify the password, password, login incorrect. So what is this? We see user Jenny again, we see a different password. So if I scroll over here, as I click on these different lines, these different pieces of text, we see these different packets getting highlighted. And you can see that the source and destination port change, right? So what is this? This is likely the attacker using Hydra, which is that brute forcing tool, to try to guess a user named Jenny, trying to guess their password. So the tool tried password, and we get 5 login incorrect. So I wasn't sure what these different status codes are for the FTP server. I wasn't sure what these were, so I looked them up in the RFC, the request for comment, the documentation that defines and dictates what FTP is. In section 4.2 of this RFC, we see something called FTP replies. And if you scroll down, it lists the different 3-digit response codes. And the first digit indicates the type of reply code. So if it starts with a 2, like a 220 here, then that means the requested action has been completed successfully, or a new request may be initiated. So this is first logging on, first connecting to the FTP server. They specify the user Jenny, and we get a 300 series reply code, which is positive. They give an incorrect password, and then we get a 500 series reply code. We scroll down here, and we see that that's negative. So it's basically very similar to HTTP response codes. Not really important. Just a neat little thing that I didn't know and that I looked up today, and I wanted to share that. So the username they're trying is Jenny. What is the user's password? Well, it's not in this stream here. So if you can see down here, we see stream 0. I'm going to click on the up arrow to go to the other stream. We see password 123456789 and Superman are both tried, and the login is incorrect. So we're just going to keep searching the stream until eventually we see password correct or successful login. Don't see it yet. Keep searching. Here we go. Login successful. Password is simply password123. Not a good password. What is the current FTP working directory after the attacker has logged in? So they're logged in as user Jenny and just asking, hey, what directory are they in? Let's keep looking. All right, these are more password attacks. There we go, stream 16. So I'm assuming at this point they stopped the brute force attack and now they're logging in through the FTP command line. They ran the command pwd, print working directory, and it prints out var www html, which is like a web directory. Hit that. The next question, the attacker uploaded a backdoor. What is the backdoor's file name? All right, keep scrolling through. We see they did a list command to see what's in the directory. We see store. What is the store command? STOR. See here, this command causes the server to accept the data via the data connection and store the data as a file on the server. So basically, it's an upload. Upload shell.php. So that's the name of the file. The backdoor can be downloaded from a specific URL, as it is located inside the uploaded file. What is the full URL? And the hint just says look at the FTP data protocol. All right, scrolling through stream 17. We see index.html. Okay. 18. We see some PHP code. PHP reverse shell. A reverse shell implemented in PHP. The description, this script will make an outbound TCP connection to a hard-coded IP and port. The recipient will be given a shell running as a current user, which is usually Apache. Some limitations, and then for the usage, it says visit this website if you get stuck, this URL. So I'm curious, is that the answer? Yeah, and it is. Which command did the attacker manually execute after they got the reverse shell? So let's look at this. We see the IP address and then the port to call back to. And then the shell variable. I'm guessing it's telling it to run these commands. Uname A to figure out what version of Linux this is. W to see what users are currently logged in. ID to get the name of our current user and what groups they belong to, and then start an interactive shell. Cool, and then this is the PHP code to execute all of that. Let's go on to the next stream. We see an HTTP GET request, get shell.php. So perhaps the victim clicked on the link, they're accessing the shell. It looks like they're logged in. This looks like the output of the uname A command, right? We're getting the Linux version and the kernel version, 4.15. It's an Ubuntu. The W command output is right here. Jenny is logged in. Here's the ID command. So we're the www data user. And then they run who am I just to confirm that again. And then they do a directory listing. So the answer for this is who am I? What is the computer's host name? Well, we see that here in the uname tech A command, WIR3, wire. What command did the attacker execute to spawn a new TTY shell, a teletype shell? So that's just like an interactive shell that they can use. Scrolling down in this output here, we see this Python command, import pty, pretty teletype, and then spawn bin bash. Which command was executed to get a root shell? We see they switch user to Jenny, they enter their password that they got with Hydra earlier, and then they run the sudo tech L, which means list all the commands that Jenny can run as the super user, as the root user. And it says user Jenny may run the following commands on this host. She can run all commands as root. Then they do sudo su. And here we can see the command prompt, right? Up here it's just $. We switch user to Jenny, and now the prompt is Jenny at the host name. But after we do sudo su, we see that the prompt switched to root. So we're the root user. So how did they do this? Sudo su. They switched to the root user, which is kind of like the administrative user on Windows. They can do anything. They're not restricted in any way. The attacker downloaded something from GitHub. What is the name of the GitHub project? Scrolling down. They changed directory to the root's home directory, CD. Before, the prompt was a $sign. Now it's a hashtag, a pound symbol. The pound symbol means it's the root user's home directory. They ran git clone to download something from this URL. Let's check that out. What is that? We already looked at GitHub earlier with this page for Hydra. Let's look at it for this. We see here it's downloading 0% complete, 1%, all the way to 100%. All right, keep going. Again, and some more. Done. So they downloaded it, they changed directory to reptile, they listed out everything that's in here. They ran a command called make to try to compile it, and then that's all we have. They got an error. So let's look at the GitHub page to figure out what this is. LKM, I believe that stands for Linux Kernel Module Rootkit. A rootkit is a type of malware that attackers install onto a system, usually for a backdoor or other nefarious means. All right, there's a picture of a Mortal Kombat character. We get the different Linux operating systems that this rootkit was tested on and the different features. Give root access to unprivileged users. It can hide files and directories. So if it creates any, if you create any malicious files, you can have those hidden. Any malicious processes, you can hide those. If the attacker makes some type of outbound connection, it can hide that as well, and so on and so forth. So this isn't good. This isn't something you want installed on your system, right? They even have a wiki page on how to use it. That's cool. I haven't seen this before. I might download it and play around with it myself. In a VM, don't install this on your host machine. All right, so it's a rootkit. It's a backdoor. It looks like they tried to install it with make and it just did not work. But let's answer this. Reptile. The project can be used to install a stealthy backdoor on the system. It can be very hard to detect. What is the type of backdoor called? We saw earlier that this is a rootkit. Nice. So that's all the questions for task 1. Let's move on to task 2. So we're done with this Pcap. We're on stream 20. We see that there's no more streams. We've looked at this in its entirety. So I'm going to minimize this and then maximize the TryHackMe window, make it a little easier for you guys to read. The second task, hack your way back into the machine. Deploy the machine. All right, hit start. You don't have to tell me twice. The attacker has changed the user's password. Can you replicate the attack steps and read the flag? The flag is located in /root/reptile. Remember, you can always look at the Pcap if necessary. All right, complete that. So we're going to give this a few seconds to load up. The IP address will pop up here, and then afterwards, we're going to try to connect to the server and figure out what's going on. All right, the IP address is populated here. The task says run Hydra or a similar password cracking tool on the FTP service. The attacker might not have chosen a complex password, so you might get lucky if you use a common word list. Let's check out the hint. The word list might rock your socks off. Okay. Let's open up a terminal. I like using Tmux just for easy access to multiple terminals and multiple panes at once. I'm gonna type the word list command, and that's gonna place me in the user share word list directory. Alternatively, you can just look into that directory and grab whatever text file you want. We're going to be using rockyou.txt. That's what the hint was pointing us towards, rock your socks off. We see it's a pretty beefy file, right? ls type L. LH or human readable. We see it's 134 megabytes. If we look at the lines, we see it has that many lines. So it's pretty huge. If I just open it up in less, just in case you guys have never seen this text file before, I think it's cool to take a look at. So this is the list of passwords that we're gonna guess. We saw this earlier when we looked at the Pcap. So I can pull that up here. Right, we saw this earlier when it's supplied user, Jenny, and then password, just these random passwords. They probably came from this file, from rockyou.txt, or a very similar password word list. So we're going to use this. It goes on and on and on. So these are very common passwords, unfortunately. They're very weak. Let's do Hydra tech H to look at the example syntax. Hydra tech L. The user is Jenny. We're going to use rockyou.txt for the password list. And we're going to be launching it against this IP address. Let me grab that again. Bam. All right, there we have it. We see the password was cracked here. It's highlighted in a different color. The password is 987654321. Just for fun, let's do an Nmap scan of this IP address just to see what ports are open. We know port 21 is open for FTP, but perhaps there's SSH, perhaps there's a web server on port 80 or 443. Because if so, these credentials should work across all of those sites and services. All right, just 21 and 80 are open. Since port 80 is open, I like to navigate to it in a web browser just to see what's up. We just get a boring Apache 2 default page. Nothing special here. We can look at robots.txt, see if there's anything there. No, file not found. All right, we'll log in via FTP. Let me clear the screen with Control L. It asks me for the user, Jenny, and then the password that we just cracked. Successful login. Let me do list, tag LA to see what's here. All right, it doesn't like that. Can do a regular list. Help. Wow, it doesn't like any of these. Okay, let's just do a simple ls, I guess. ls tag LA. There we go. We get index.php and we get shell.php. Let's download the shell. We get permission denied. All right, let me open up a new pane. There's a few things we can do here. We want to execute our own web shell that calls back to our IP address and gives us remote access. We saw that in the packet capture, right? If we keep going through these streams, we see that shell.php was created. The user downloaded it, they clicked on the link, and then it popped open a shell for them. Essentially, it created that callback. So how can we do that? We want our own PHP web shell. We can go to that URL that we saw earlier from Pentest Monkey and download it. Or since we're in Kali Linux and it has a bunch of things by default, we can just go to the web shell directory. Or just type in the web shells command. That's really cool. I didn't know if that was a thing. I literally just tried it out now. And here we are. We see the different web shells. Let's do an ls. We want a PHP ls. Let's just grab this PHP reverse shell. That's the most stable. I'm gonna copy that. Let me just move it to the temp directory. cd into temp ls. All right, here it is. Let's open it up in Vim. We're just going to have a few things that we need to change. This should look pretty familiar. It's the same file that we saw here. The same exact file. All we want to do is change some of these variables. Let's change the IP address. In the bottom right hand corner, you see I have two IP addresses, two interfaces. We want to use the TUN0. This is the VPN for the TryHackMe server. It'll be a different IP address for you. And let's change this port. Let's do it to something that blends in just a little bit. Let's change it to port 80. That's good. :X to save and exit out of there. Now we're back on the FTP server. Let's run an lpwd to print the current working directory of my local station. which is user share word lists. Let's change that with lcd to temp. Cool, now I'm in the temp directory, and I want to upload that reverse shell. Upload it. All right, it says transfer complete, ls, and we see that our PHP reverse shell has been uploaded. Let's create a netcat listener on port 80. And now we need to make an HTTP GET request. Just like we saw in that packet capture, all that means is all we have to do is browse to that website. I'm gonna try to showcase two different ways to do that. All we have to do is navigate to the IP address and specify the PHP reverse shell. This simulates the user clicking on the link, hit enter, and we see that it's loading. But if I go back to my terminal, seems like it's hanging. Let me try to curl PHP reverse shell. Nothing. Let's make sure it's still there. Timeout. Not connected. Exit. Reconnect. ls-tech-la. All right, it's there. I'm not sure why I'm not getting my reverse shell connection. Let's try wget. Internal server error. Looking at it, is it because of the permissions? We see that the permissions here for the shell are read, write, and execute, but the permission for mine are not. It's not executable. I wonder if that's the reason why. ls-tech-l PHP reverse shell. All right, the permissions are good here, but they don't look very good on the server. Let me do a question mark. Is there a way I can change the permissions? Oh, there's a change mod command. Help change mod. Is it the same on Linux? Change file permissions of remote file. Change mod. PHP reverse shell. 777. What's the syntax? Change mod 777. PHP reverse shell. All right, ls-tech-la. Now it's executable. So now when I click on it and run it, it should work. Let me issue a wget. Bam. So wget, just webget download. I'm just doing that from the command line. I'm saying, hey, go to this IP address, the server, and get the PHP reverse shell file. I reached out to the server. If we had a packet capture going on, it would look very similar to this GET request, but the host would be our IP address and a different user agent string, and we have our shell, right? It did the exact same thing as we saw in the packet capture. It ran the uname tech A. It ran W. No one is logged in currently. And we have, we're the www data user. All right, I can do W. We see again, no one's logged in. Sudo tech L. I can't do that. There's no teletype present. Let me zoom in. Let me make this bigger. I'm gonna go here. Exit out of that. we're going to grab that little Python line, that piece of Python code. We're going to upgrade our shell. Now can I do sudo tech l? Yeah, I don't have the password for this user. I hit Control C and it killed my connection. That's very sad. Do that again. So I don't have the password for that user, but I do have the password for Jenny. I didn't want sudo su. That was a mistake. Let's paste that in. Let's hit Control Z to background it. Let's make this shell more secure, more stable. Go to my website. Log, Control F, stable. I have my notes here. How to stabilize a reverse shell. You see I wrote this in 2020. All right, so we already did this line. We got our bin bash shell. Control Z to send it to the background. STTY, raw minus echo. And then foreground it. And then get a new term window. Paste that in there. Export term equals xterm 256. Does it like that? No. Xterm. All right, it doesn't like any of those. All right, I tried. It usually helps, so you can do things like hit Control C or you can clear the screen, but it's not having any of that today. So anyway, let's switch user to Jenny, enter their password, and now we're the Jenny user. I'm not sure why the password showed up in clear text like this instead of being hidden. But oh well. ls tech la. All right, we see what's in there. Let's do a sudo tech l. See what the user Jenny can run as root. They can run all commands as root. Let's do sudo. We could do sudo su. We saw that in the packet capture, but I'm curious if we can also just do sudo bin bash. Yeah, that works as well. We see that we're the root user. ls tech la. Let's go to the home directory of root. We can look at the bash history if we really wanted to. It just directs to dev null. So we're the root user. We have access to essentially this whole server, this whole file system. What does the challenge prompt want us to do? It says read flag.txt inside the reptile directory. ls/root. Let's cd into root. Oh, I can't tab complete. ls tech la. We see flag.txt. Let's cat that out. And we got it. Cool, that's it for that challenge. But since we're on the server, let's play around. Let's have a bit more fun. This is just like a bonus playing around. Let's navigate back here. We see that it's the Apache 2 default page. We saw earlier that there was the var www h10l directory. let's cd into that, and we see the files that we uploaded. We see the reverse shell that we're currently using to access this server remotely, and we see index.html. Do I have Vim installed? Which Vim? Cool. I'm the root user, so we can do everything. Oh, I messed it up. Hit enter a few times. Vim index.html. Ooh, this looks terrible. Yeah, this looks very bad. So there you have it, guys. If you want to play around, you can open up this index.html file that was on the server and change it, configure it. That's how I solved this challenge. I know it was kind of slow going. I was trying to explain all my steps as I went along. Let me know in the comments below if you found this helpful or if you found a different or better way to solve the challenge. As always, take it easy and see you guys in the next video.